let me go over briefly the threading technique that we're going to be using. So we're cutting a 2.5 metric pitch on that. We are using a lathe that has an Imperial 4 threads per inch lead screw on there, meaning that once you engage the half nuts here on whatever you start, the very first pass, you have to keep it on that exact line throughout the entire threading cycle. Meaning you can't let it rotate around and line back up again on the half nuts. It won't work, you'll never line up. So let me show you what it is that I'm talking about, the way that I do this, okay? So we'll go ahead and turn the machine on. We've got it, let me just back it out a little bit more so that we don't risk crashing into any shoulders there. All right, so let's, I'll wait for this one to come back around. This is the one I usually use the yellow dot, okay? So say we're ready to start our scratch pass. We engage it right there. All right, normally you stop it, you can hit your foot brake, right? Stop it right where you want it. And then you simply reverse it, let the tool come back and clear, stop it, hit the foot brake, go back in with your desired cut depth, forward, come back in and slam on the brakes if you want to and stop it right in that thread relief. Or you can use the technique that I like to use, which is where you actually disengage the half nut there. Let's go ahead and just, let's back it up. All right, let's pretend that we're gonna make the cut. We come down to our thread relief, bam. Disengage the half nuts, you see our dot. Stop the machine, reverse it. Let this come back around, engage it, clear your part, stop the machine. We're ready to go back in our desired cut, go forward, disengage, stop the machine. You don't have to be in any big hurry. The main thing is you have to keep up with the rotation of your number, okay? So if you let this machine idle down and it comes all the way around 1 revolution, you need to reverse it and bring it back 1 revolution and line back up. So we'll reverse it, line up with our dots, stop the machine. Now the reason why I like using this technique is that when you don't disengage, you run the risk of snapping the tool either by stopping the machine too soon and not clearing the material, or you go past it too far and you end up hitting your shoulder. The other cases why I talk about this is that there's sometimes, this is very large diameter right here. It might be a flange or a large shoulder like this right here. Imagine you were threading this. You can't stop the machine fast enough and let everything slow down before crashing the tool in there. I'm not saying you can't do it. I'm just saying it's risky to do it that way. When if you do it this way right here, disengage the machine, calmly stop the machine, reverse it, line the number back up with the half nuts, and then stop it out here. It's a great technique and it works every time. I'm sharing this because I'm trying to be helpful and help some of you guys out, and maybe this will help you out with your work there as well. All right, so let's get started cutting that thread there. We'll start our scratch pass so we can verify our pitch is correct. That looks right. going to go ahead and measure that and see how far off we are on our pitch diameter. It gets a little tricky right up here next to the tool, and of course I'm trying to show you guys as well, so everything's going to be kind of in the way here. There we go. Okay. Feel squared up nicely. Yeah, we still got a little ways to go on this. I'm almost positive our tool is going to end up scratching this area right there, and I looked closer at the original workpiece. It looks like they actually undercut it a little bit where their tool goes in. It was done on a CNC machine, so they were able to bring that tool just in that spot and thread it. Like I said, it's going to scratch it. We're getting a little closer, so I'm going to go ahead and start using just a little bit of our cutting oil there. This one's gotten real tricky because of the depth of this thread. I think this is going to be my last pass. I'm having to, it's actually trying to touch this undercut, so I'll have to go in there and actually trim that undercut a little bit, and we'll trim that radius there as well after the thread is cut. Let's make one more cut and see if I land on our pitch here. And what I'm going to do is, well, let's just go ahead and back it up. All right. The bottom, hook the top, and then come into the center. All right, and we have landed on our, let's see if the camera will focus on this guy right there. 1 inch, 12 thousandths. That's exactly where we wanted it right there. So I'm going to go into that undercut there. That's for a set screw, and I want to clean up that thread there. So that diameter is not critical. Okay, I'm not even moving you. And then the radius there for the thread relief, I want to clean that up there as well. Take that just a little bit deeper and just clean that up overall there, make it look a little nicer. I've been polishing the bearing journal here. We're going to use our Starrett digital mic here so that you can see the size that we landed on here. I'll measure it in 2 different places. We were looking for 0.9847 as a maximum diameter. 0.9846. .98465. So we landed right on our maximum tolerance there for our bearing journal. We have got this side of the shaft now completed. All the journals are polished to size, We hit our bearing fit exactly on that one right there. Same thing with this bearing fit here. We landed on our maximum size allowance there, which actually is going to tighten this up because the stock shaft was actually undersized from what the spec should be for a proper bearing fit there. So that should help that out a little bit. But all the journals turned out nice. Even our thread looks nice right there as well. So time to remove it, flip it around, and finish out the spindle nose side of the shaft there. All right, guys, we've got the TMX 4-jaw chuck mounted on the lathe here, and this is going to work out really well for helping me machine the second side, the spindle nose side. So we've got this undercut area right here, right? And it works out perfect that these jaws are actually a little bit more narrow than the width of this undercut here. So we can put the shaft in here and just chuck in this area right there and not even have to worry about using soft jaw pads or anything like that to protect the surface from out here from getting marred up. So that's what we're going to do. We've already got it preset, and then I just move out 2 jaws to give me clearance to get the shaft in there. Try not to scratch it going in there. I try to pick it up so that it doesn't actually rub on the jaws. All right, and let's get our indicator on here. And this is going to work really well because now we're right on this bearing journal here. And making sure, and because this being a new chuck, it doesn't have any wear in it, so to speak. So the jaws should be perfectly straight in line. We should not have a shaft in here. The spindle should not be running out in any way. It should be perfectly concentric once we get the OD true. Hey, I got that pretty close right off the bat, about 12th thou. So we'll just go ahead and let's just snug up the highs to get the jaws tightened up. Low, high, so you loosen your lows and you tighten your highs. Just light movements for now, not over tightening it. Just want to get it kind of centered, which there it is right there. Now we got to go back in there and make sure all the jaws are tight. And you'll go back and forth with this because you'll go past center because you got to get enough torque on the jaw so that you're holding it. You don't want it to slip or push back in the jaw. That right there is near perfect. I see maybe 1 or 2 tenths of movement on that needle, but I need to get the jaws a little bit tighter because I don't feel confident that they're tight enough, and I'm not over torquing it. I just have a feel for what's good. So I'm going to go ahead and go around all 4. I'm not even looking at that, and I'm just going to snug them so that I know that they're torqued. That should be good right about there. And I moved it about 1 thou. So I'm going to go back to the high. Try to move it about 1/2, just about there. Just tighten the high. That's about 1/10, maybe. That looks good, right about there. We've got maybe 1/10 movement in that needle. So that should be good. We are ready to get this other side machined now. I'm just going to work through this. No need in doing a bunch of explanations. We got an 1¼ 8 thread that's going to go here, so we'll finish this at 1.248. This little register right here helps center up the chuck. This measures 1.249, so we'll get this turned to 1.249, and then I'll just skin another 4th thou off this, and then I have a dimension that we turn this to. But I think there's nothing that actually fits this area right here, and it just provides a shoulder and then clearance behind the chuck there. And then of course we'll finish out these 2 faces there as well. So actually I need to measure it and see where we're at. I usually shoot for 40 to 50 thou oversize when I'm roughing. 60 thou works good too, because then that gives you approximately 3 equal 20 thousandths cuts to finish it out. So yeah, we're at 309 right there. So that's just about 60 thou or it is what we need to come off of it. All right, let's get going. Get my feed set up here. I've already got my link set on my DRO. I'm going to stop and do something here on my DRO. I'm going to set me an absolute X to 0. Come back into my incremental, finish out this. What I wanted to do was feed in from the outside in to clean this face up nice. And then we'll just have to take this down about another 1/4 thou. Yep, 249. So let's take another 4 off that. That'll give us clearance for our thread. All right, there we go. All right, now we're just going to finish this diameter in that face there. And I'm working off my DRO up here. We've already got the tool set to this diameter. Make 2 cuts and then face it. I'm going to verify it again with my micrometer. And it is right on it. So let's take it into 2 inches, 48 thousandths right there. Come into my 0. That'll be our face. Inch 48. We are good to go. Let's get some chamfers on there. That other one I'm going to have to reach in there with a different tool. Probably just use the threading tool to chamfer that little register there. I just want to hit these other 2 corners with this threading tool before we begin our threading. Actually, let me see if I can do this, get a little bit more angle. This is one of the beauties of the multi-fix, is being able to index that around a little bit. Add another 9 degrees to that angle. Perfect. Just break the corner off. And then we'll come back and let's hit the back side of this thread here. All right, and then while we're at it, let's put some blue marker on it so we can highlight it. Now I want to go get some measurements using my thread triangles and measure our pitch diameter. I'm going to use Granddad's thread triangles to measure the pitch diameter of what the factory machined this to, but we'll also use the chuck as we get it close and kind of use that as a go gauge on there. So one of the things I want to point out about the thread triangles is that the three sides of the triangle have different width flats ground on there so that you can use the one appropriate to clear the root of the thread there. So they used the tool that had a slight radius to it, so you don't want to use the sharp corner of the triangle because it's just going to rock on that radius in the bottom. I'm using the one with the biggest flat ground on it so that it sits down in there square against the V thread, okay, without touching the very bottom of it. So let's see if we can give this a go. Just making sure that I'm lined up good here. We'll give that a try right there. It's a little tricky, but what I do is I try to hook the bottom with the anvil and then just come in on the top to just capture it all like that. And then come in with the measurement. That doesn't look right though. Let me back out here, try this again. Go over one thread, there we go. This might be about where I need it right here. Okay, that's looking good right about there. So I am looking at the mic just to watch the measurement change, and I'm feeling it as well, making sure that it's squared up nicely there on the thread. You'll feel just a little bit of movement and rock, but you'll feel everything square up nicely. And that feels like a good measurement right there. Check it again. I'm just kind of moving it. I'm looking at the bottom anvil here. All right, and then let me go ahead and pull it off here. So I'm getting a measurement of 1.452. 452.3. I'm going to go ahead and lock this in, and I'm going to write that measurement down here on my pad, and then I'm going to double check this a couple more times and make sure that I'm getting the same measurement, and then I'll know I'm good, and then we'll go from there. Just going in with my triple check here. 1.452.3. I got the same measurement there again. All right, so I'm going to put 1.452.5 there just to kind of give myself a little bit of extra. So this is going to be our target that we're looking for right there on the pitch diameter as we start threading this in. This is a diamond lap that I've got in the device here, and what I'm doing is using it to hone more of a radius on the tip of this tool. Since these are ground pretty sharp, I want to match the profile of the thread a little bit closer than what just the thread insert gives me. So I'm just holding it as square as I can against this diamond lap like that. And looking at it, and then I'm walking over here to the thread, and I'm laying the tool in there, and it's getting very close. So I'm going to do that one more time, and I think we'll have it. I don't have a carbide grinder here in the new shop. That's something that I'm wanting to add to my arsenal here. I just haven't gotten one yet. But a diamond lap will take care of little things like this as well. That's looking pretty good. I've got the spindle mounted over here in the other vise, so that's looking pretty good. I think we're going to roll with that right there. Let's get our tool touched off and get this threading underway. We'll get it touched off and I'll tighten up the shot so you guys can see it a little bit better. Got my the cross slide set to 0. DRO set to 0, and we're using our top slide here to touch the tool. Right there. Now let me get this set to a 0. Let's double check that we're on the right settings here. So we're going to be cutting an 8 thread LBT1V, LBT1 and V. Alrighty. Now for this thread in here on our half nuts, because we're cutting an 8, we can engage this anywhere we want on that dial. We don't even have to look at it, we can just engage it. And if you have any question of that, you can always look at the chart underneath it. It even says 8 any position. That's because 8 is divisible by 4. That's a 4 pitch lead screw. All right, let's get to cutting. Make a scratch pass. And let me find my pitch gauge. I set it down now, I don't know where I set it down at. Oh, here it is, right in front of my face. All right, so we want to double check it that we're cutting 8, and we are. That verifies 8 right there. I'm going to go ahead and give myself a measurement here to see where we're at on our depth, just to kind of make sure that we're not overshooting ourselves. It gives me an idea how much further to go. So we said 452.5 is our target. Right now we're at 75, 80, 90, so we're at 492. So still got 40 thousandths to go on our depth. We still got about 10 thousandths on the pitch diameter, but I want to go ahead and try the chuck here because I don't want to cut it too loose. Get it squared up. See, it's already trying to go on there. All right, so it's still too large, the diameter, but we're really close there. So I'm gonna do this. I'm just gonna take very light passes here, and we're gonna check it against our chuck here and make sure that we get a good fit on that versus exactly what we're trying to hit on our pitch diameter. But that got us close right there. I think we're right about where we're going to be, so I went ahead and just hit the top of the file there and make sure there was no burrs. And you can see that it is screwing on there, and it's going over our register on the back and going right up to the face there. I'm going to back off just a touch. There literally is very little movement in that at all. So we're technically there, but what I would like to do, and I'll show you guys this. So we're definitely not going to go off what the original pitch diameter measured on the stock spindle. We want to make this more a custom fit. But let's also see what my thread triangle chart says that the proper pitch diameter would be for an 1¼ 8 thread. All right, let's show you guys my little secret item right here. This is the chart that comes with the triangles, or came with the triangles. I don't even know if anybody is building these anymore. I haven't researched it. So this chart here is going to give you many of your standard industry sizes right there, starting from a 0 all the way down through your standard sizes down to this 1/2 inch, and then we continue on to this side from 9/16 down to 1.5 inch in industry standard pitches. Many cases you're machining something that is not an industry standard size that's commercially available. You're cutting something with a custom pitch, which is what we're doing here. So 1¼ 7 is your standard coarse thread, 4¼ inch. We're cutting 1¼ 8. So if you look down here, this chart right here, A, so there's 8 right there. So what we do is we're going to use a calculator here. Our nominal size is 1.250, that's 1¼ inch, plus 8, add the column B to that, 0.2106 equals 1.460 6/10. That's for a class 4 fit now. That's not a class 2 or 3. Class 4, which is considered a close fit, which is what I want. That's what a lot of machinists want. You want a machinist fit or a class 4 fit. So this is actually our target that we would be shooting for when we're measuring if we want a class 4 fit. All right, so 1.460 6/10. Let's go measure with our thread triangles and see where we landed on that last pass there. 1.460 6/10. I bet you we're going to be pretty close. All right, as usual, we just we keep working the mic, make sure that we're absolutely squared up on our thread. All right, we're going to pull that off, catch the triangles, set those down up here, and we are currently at 1.462 7/10. 462 7/10. So we're technically a thou. I'm sorry, 2 thou. 2 thou over what our industry standard would be. I think what I'd like to do is make a couple of spring passes on here without feeding in anymore and see if we can get maybe another thou out of that, but also just to kind of help clean up the thread, although it looks pretty good where it's at. But I think if we can get one more thou off that pitch diameter, make me feel a little bit better about that fit. Wasn't much there. I don't think we're going to get much off of it. Go back to our 0. Not really getting much off of it. So I'll tell you what I'm going to do. Let's go back to 0 again. I'm going to just barely bump this compound in just a smidge. I don't know how much a smidge is, but we're going to go for it. Not much. Go about a width of a line on the cross slide. I don't know if we took any off the diameter, but we're gonna measure it and see. The thread looks beautiful. I mean, it's really got a great finish to it. So my main concern is if he has a different accessory that's going to go on here, you know, that's not the 4-jaw chuck, but something different, a face plate or anything. I just want to make sure that whatever goes on here is going to fit it, you know. We're at 462. So we're still 1 thou and 4/10 over what we're supposed to be, but I really don't think that that's going to matter, because I think whoever manufactured these threads have got them just a little bit oversized. I mean, that is, I really don't want to loosen that up any more than it already is. I think we're going to call that good right where it's at, guys. That has a really great fit. That has a machinist fit to it. You can feel just a little bit of rock in it so that it's not super tight. And it's gonna, I'm gonna turn that coolant pump off. I'm just gonna screw it up on there. Tell you what, let me go in the high range, move this rest down here to hold that lead screw. What do you think? I think we got a great fit, and we should leave it alone.